Here are going to be a few examples that will be helpful in the skills for short-run behavior with polynomials, going back to factoring, some solving equations, some finding zeros. So we'll start with factoring. A few examples here. The first thing you want to try to do is identify any greatest common factors that you can factor out first. So in this first problem, the x to the sixth and the x to the fourth term have x to the fourth in common. And if we factor that out, we're left with x squared minus 1, because we still have to have somewhere to hold the place where the x to the fourth lived. And then, if you notice, what you have left in the x squared minus 1 is a difference of squares. Well, it will factor further to x plus 1, x minus 1. The x to the fourth just comes down and gets multiplied, and the x plus 1, x minus 1 are what are called linear factors, and those are as factored as they can get, which is what we want moving forward in this section. So the factored form of the first one is x to the fourth times x plus 1 times x minus 1. And for the second one here, there are 3 terms, but they all have an x in them. So if we factor that out first, we're left with x squared minus 6x plus 5. Now you have a trinomial, the one with 3 terms. So it's best to try to factor that into 2 linear factors. X squared will break apart into x times x. And then the end 2 terms need to be, something that multiplies to give you 5, positive 5, but adds to give you negative 6 in the middle. So those two products, that'll be negative 5 and negative 1. And then the x out front still carries. So what you have is an x times an x minus 5 times an x minus 1, and that is completely factored into linear pieces. Okay. For this third one, there's only 2 terms, but they both have an x, so we'll factor that out first, leaving us with 16 minus x squared. The 2 terms that are left are, again, another difference of squares, where 16 is 4 squared and x squared is x times x. So 16 minus x squared will factor into 4 minus x and 4 plus x. Again, those are linear factors. You can't really do anything else to them. So that's the factored form for the third one. Okay. The next step up from that will be solving the equation using the factoring, because if you can get it into the factored forms like we have here, then you can set each of those factored forms equal to 0 and find your solutions. So for this first one, we've got 2x cubed minus 2x equals 0. You do want to make sure first that it is set equal to 0 before you start factoring to solve. So they each have a 2, they each have an x, so I'm going to factor a 2x out from both places. So I'm left with x squared and a minus 1. The x squared minus 1 is again a difference of squares. So I'll do x plus 1, x minus 1. And now that I have linear factors in parentheses and a single 2x out front, I can set each one of those equal to 0. 2x equals 0, x plus 1 equals 0, and x minus 1 equals 0. And that will give me solutions of x equals 0, x equals negative 1, and x equals positive 1. So my solutions here, which because we set them equal to 0, will also be known as zeros in the next part, are in increasing order: negative 1, 0, and 1. All right. The second one is already sort of factored for us. Even though there's a 2 in common in the x plus 4, you can factor it out, but it doesn't really help with solving. So we can set each one of those factors equal to 0. So 2x plus 4 equals 0, x minus 1 equals 0. The left solution gives 2x equals negative 4, so x is negative 2. And the right part gives the solution of x equals 1. So the solutions here in increasing order are -2 and 1. And it's not the point -2 and 1. Those are two separate zeros or x values or solutions to where the function equals 0. Okay. So the other set of directions that you'll see, which are similar, are find the zeros. And that's where you actually set the function equal to 0 like we just had in the last problem. The thing is, those are going to get more complicated in solving, and you may have to use different factoring methods as well as the quadratic formula. So for this first one, it is already factored. There's a 7, an x plus 3, an x minus 2, an x plus 7, and we can set each of those pieces equal to 0. The 7 being set equal to 0 is useless here because there's not an x in it, so you don't really use it if it's just a coefficient. So then we get that x plus 3 is 0, so we get the solution of -3. X minus 2 is 0 with the solution of 2, and x plus 7 equals 0 with the solution of -7. So here the zeros in increasing order are -7, -3, and 2. All right, for this next one, it's not factored. There are 3 terms. They do have an x in common, so I'm going to factor that out first. And I'm left with x squared plus 7x plus 12. And then I have a trinomial, which I will attempt to factor into 2 different linear pieces, but if it doesn't, we may have to go with the quadratic formula. So I get x and x, and then I need 2 numbers that multiply to give me 12, but add to give me 7. So that's going to be a +4 and a +3. And now that that's factored, we can just set each piece equal to 0. So x is 0, x is -4, and x is -3. And those are the zeros for that problem. All right, third problem at the bottom. Many terms. Highest power, I think, is going to be 5th here, but we're not trying to multiply it out. We're trying to factor it apart. So the first trinomial, if you look at it and try to factor it, and you try to come up with 2 numbers that multiply to give you -7 but add to 2, you will not be able to do that for this problem. So this will not factor, but you don't have to complete the square. If we want to find where x squared plus 2x minus 7 equals 0, of course you can graph it and find the x-intercepts, but we're going to go through and use the quadratic formula in a minute. I'm going to try to tackle this other one. It's also 3 terms, but they have an x in common. So if I factor an x out, I'm left with x squared plus 4x minus 21. And in this trinomial, let's see if it'll factor. We've got x times x give us x squared, and then 2 numbers that multiply to give us -21 but add to 4. So that's going to be a +7 and a -3. So we have the factored form x squared plus 2x minus 7 times x plus 7 times x minus 3 all equal to 0. And for 3 of these pieces, we can set them equal to 0 and find that x is 0, x is -7, and x is +3. But for this other quantity, we're going to have to go through and use the quadratic formula to come up with that. So using the quadratic formula with an a value of 1, a b value of 2, a c value of -7, we get that we have -2 plus or minus the square root 2 squared minus 4 times 1 times -7 all over 2 times 1. So it's -2 plus or minus the square root of 32 over 2, which will simplify to 2 plus or minus, see, 32 is 16 and 2, so square root of 16 is 4, 4 square root of 2, which will simplify to -1 plus or minus 2 square root of 2. So you have 0, -7, +3, And then the two answers from the quadratic formula add two more answers, so there's really 5 zeros in all, in which you'll be expected to answer in increasing order. So go ahead and estimate the decimal for the square root ones, but there are 5 answers here for this one, which is expected. If you multiplied it out, the leading term would be a 5th power, but you may have to use other methods besides factoring to solve for zeros, and the quadratic formula is a prime example of that.